Right, I want us to look at the third grade 12 theorem, Similarity Theorem. Before we tackle it, I want us to come back here. Remember the first theorem that we dealt with? It's triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. Isize ngaleya theorem, isize ngokuthi sikwazi ukuchaza le theorem, ekuthiwa i-proportionality theorem. It's a line drawn parallel to one side of a triangle divides the other two sides proportionally. Now, sisebenzise leya theorem ukuprova le. Now, this next theorem ithini? If two triangles are similar, then the ratio of their sides are the same. If two triangles are similar, then the ratio of their sides are the same. So this theorem, we prove, so sizwe le theorem, esiyibiza ngani, proportionality theorem. If two lines are parallel, a line drawn parallel to one side of a triangle, it will divide the other two sides proportionally. Right, so before we prove it in the theorem here, if two triangles are similar, because triangles are similar, because ayafana. Like wena, uyafana nomzali wakho. Uma umzali wakho enamehlo amakhulu, you are likely to have amehlo amakhulu now, and lawo mehlo amakhulu should be at the same position. Amehlo wakho mayela, nawakho kumele bela, amanye angabi semadolweni. Therefore, we call that similar. They must be at the corresponding position. When it comes to triangles, it's the same thing. These two triangles, even though if le inkulu, but like this one, if this angle must be equals to that one, we said that these similar triangles must have equiangular angles. Equiangular means corresponding angles are the same. Well, this angle will also be equal to that one. You see them, they're sitting on the same position. And angle C corresponds with angle F. Corresponda chaza lokho corresponda. Uma mina ngila ngenza maths kaYunisa. No send impompo enza maths through Unisa siya corresponda sonke kaYunisa. Sonke sikaYunisa corresponda khona. So this one ihleli the position efanayo naleya. Nale ihleli position efana ayafana futhi nale ayafana. So similarity fala kube khona izinto enjengalazo. Those corresponding angles must be the same, equiangular. Like in most theorems, when we prove them, we have construction. Right, let's look at what we're given here. We're given two triangles that are similar. But while these two triangles are similar, what does that mean? It simply means that this angle is equal to that angle, and this one is the same as angle B. That's angle E is the same as angle B, and angle C, I'll indicate it with 3, is the same as angle F. So these two triangles are equiangular, meaning that their corresponding angles are the same. So this one is equal to that one, this one equals to this one equals to this one. Then we can say these triangles are similar. The theorem says if two triangles are similar, if you've got this situation, then the ratio of their sides are the same. Or little side over little side will be the same as this side over that side, will be the same as this side over this side. That's what we're proving. If we're given similar triangles, is it true that the ratio of their sides will be the same? This over that, is it the same as that over that? Is it the same as this over that? We'll just prove two, then we'll conclude on the third one. In other words, we'll just prove these two, then similarly, in the same way, BC will be equal to EF. Let's do the thing. Let's do our construction. Construction here becomes very important. Once you do your construction right, the whole problem will be easy. Let's do our construction. Let's construct this line here. Let's give it a name. I've got F, let's call it GH. GH. We are constructing a line GH, but you construct it in a particular way. So construct GH such that, let's write it, construct GH such that, that is important, such that AG becomes equals to DE as well as, and AH, let's make it equals to DF. This is what we're getting from our construction. We've just put a construction, GH, such that this side is the same as that side, this side is the same as that side. What is this saying to me? If I take this triangle and put it exactly here, what will happen? It will give us something that is exactly the same as the other one. There comes another term, congruency, equal in all respect. Something that is equal in all respect. Number 4 cases of congruency. First one is side, 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 angle, side, angle, angle, side, 90 degrees, hypotenuse, and the side. Those are the 4 cases of congruency. Congruence means those 2 figures are the same, like identical twins. So that is what congruency means, identical twins. But similar, similar. Congruent, like twins, identical. So when you say this triangle is congruent to this triangle, isn't it exactly zonke? Amadlebe alonga la wokuqala afana nawesibili, amehla afana, indololwane ifane, izandla ifane, height the same, the age the same, parents the same, isibongo siyafana, everything is the same. So these 2 will be equal in all respect. But when it comes to mathematics, isenzela izinto zibe lula. Asicheke yonke into. Sibheka izinto ezintathu kuphela. Number 1, ama-cases e-congruence sithe ubani side, 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 angle, side, no angle, angle, side, no 90 degrees, hypotenuse, and the side. What does this mean? What does this mean? Ithi lento, mangithi side, angisho side lento yodwa, ngisho ama-side awo mabili. Mangithi amehlo, sibheka amehlo awo mabili abantu esibacombinationayo, esithi they are equal in all respect. Mangithi side, ngisho leli side naleli. Uma leli side lingana naleli, that's one side. Lo side wesibili uchaza ukuthi mhlambe leli side silinganise naleli, that's 2. Elesithathu mhlambe sikhuluma ngaleli side, siku-check ukuthi liyalingana naleli. If sinalesa simo, kobe these 2 triangles will be equal in everything. Asibheke yonke sibheke izinto ezintathu kuphela. The side le yodwa naleli linye, the side lesibili naleli linye, lesithathu ngokufanayo. Then we can conclude the congruence there. This one, side, angle, side. Check side, if side naleli lingana, the angle, included angle, the angle must be an included angle, naleya angle, plus the side, then you can conclude that those 2 triangles are the same. Or angles are 2, the side and lodwa. Or 90 degrees hypotenuse to the side on both triangles. Then you can conclude that those 2 triangles are congruent. Equal in all respect, unlike similar. Remember here we're dealing with similar triangles in this particular case. We've just done our construction. We've constructed to G. Let me just call this 1 and 2. 1, 2, G1, G2, H1, H2. All right, this is our construction. We've just constructed line GH such that lil side lingana lil, na lil lingana lil. That's what we've just constructed. Let's move on from there. Now I'm going to use these 2 triangles that I see. This triangle and this triangle. What do we see from there? In triangle, prove a manje. We are going to prove in triangle AGH, as well as triangle DEF and triangle DEF. So these are the 2 triangles that we'll be doing our proof on. What is it that we are proving? We are proving that these 2 triangles are equal in all respects. Remember, there are only 4 cases of congruency. Side, 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 angle, angle, side, 90 degrees, hypotenuse on the side. If we can prove one of those, then the 2 triangles will be congruent. Why do you have to prove that those 2 triangles are congruent? I'll tell you now. Let's move on. Spiral triangle, spiral triangle. Zikhona izinto ezifanayo lapha. Yes, we know that UAG is equals to what? AG is equals to DF. Is it F? AG is equals to DE. Yes, DE. AG is equals to DE. Yes, lil side, lingana lil side. Sithathe block, there must be a reason for every statement. Why do you say AG is equals to DE? Sithathe construction. Remember, we constructed such that AG is equal to DE. So we got this information from our construction. from construction. Right, that is side. Side prove so is side and load. All right, let's look at this diagram. You can see that we're given that these two triangles are similar. Ukuthi ama-triangles, le triangle encane nale enkulu are similar. Ukuthi lama triangles enkulu nale encane are similar, chaza ukuthi they are equiangular. In other words, their corresponding angles are the same. So this angle will be equal to that one. And the triangle encane, not the triangle in this particular case, AGH. AGH, now DEF, the angle A is equal to angle D. We are given by the fact that they are similar. These two triangles are similar. Then we can say angle A is equal to angle D. We are given that. Or similar triangles, if you like, because these two triangles are similar. Right. Let's prove man. Guys, I prove each side. Let's prove man the angle. The angle man. Let's check if you can find sides that are the same. Side, the angle. Let's check these two sides. AH is the same as AH is the same as DF. This side is the same as that one. Why are these two sides the same? We got it from our construction. GH such that AG is equal to DE and AH equal to DF. We're using that information from construction. We got it from construction. Right. Let's move on. What is this? What is this? It is a side. So we've got isn't this entire to manage as a chaluktin. Therefore, we can conclude that, therefore, we triangle AGH, this triangle AGH, is congruent, equal in all respects. That's a sign for congruent to triangle DEF. DEF. Where do we get this information from? From this side angle side. We prove that side angle and the side are the same. Congruence. Now, we can say that this triangle is equal to this triangle in all respects. In other words, they are congruent because we have proved that two sides and an included angle are the same. Right. Now that we know that those two triangles are congruent, kusitshela ukuthini lokho? Asingayikhohlwa into esiyifuna thina. Sifuna ukuprove ukuthi u-AB ulingana no-DE. U-AB over DE is equal to AC over DF. We want to prove that this side over this side is equal to this side over that side, also equals to this side over that side. Right. Let's move on. We can now look at these two triangles. What is this saying to us? Once we say this triangle is congruent to this triangle, we're meaning that the corresponding sides are the same. We're getting that from the fact the two triangles are congruent, as well as the corresponding angles. We also mean that this angle is equal to this one will be equal to this one, G1 will be equal to angle E, so congruence log. H1 will also be equal to F. In other words, if I take this triangle, exactly because this will be exactly on top of it. Right. So what can we say here? We can now safely say G1. We can say G1, angle G1. Do you see angle G1? Yes, we can see angle G1. It is equal to what? Angle G1 will be equal to angle E. Where do we get that one from? From congruency. Angle G1 will be equal to angle E. We got this from congruency. Your reasons are important. We've just proved that angle G1 is equal to angle E. From the bigger picture, in other words, from the original triangles, we also know that angle B, do you see angle B here, is equal to what that side? We're given that angle B is equal to angle E also. We also know that angle B is also equal to angle E. Where did you get that one from? We were given that originally. But the fact that these two triangles are similar, the corresponding angles are equal. And this one goes with that one. So angle B is equals to angle E in this case. That we were given in the original statement. Because the two triangles are similar, I find. Therefore, the corresponding angles must be the same. Right. Let's look here. G1 is equals to E, as well as angle B is also equals to E. Ulingana nobani G1 no E. Ulingana nobani B no E. Uchaza ukuthini ngalo wamabili? Kusho ukuthi wamabili nawo ayalingana. Why ayalingana? Ngoba wamabili alingana nobani no E. Let's write that down. Therefore, we can conclude by saying G1 is equals to angle B. G1 is equal to angle B from this information. Why are they equal? They're both equals to angle E. Omabili lama angles alingana no angle E. Sikhuluma ngobani manje? Sikhuluma ngoba. Remember what I said to you. Ngithe makabe sosebenzisa le theorem, must prove the theorem so sizwa ileya. Leya fanele ibe nani the theorem? Fanele nomunye ulana odobe parallel to one side of a triangle. That's what we are trying to get in here for us to be able to use the theorem. Now let's move on. We are saying G1 lingana no B. Let's look at those in the diagram. Where is G1? This is where G1 is, and this is where B is. And those two triangles, what type of angles are these two? This one, if I've got a line like this, and this line, I've got this line and this line. I don't know anything about these lines, but there's something that I know. If I draw a transversal line there, this angle and this one are called corresponding angles. They are corresponding. The one is on top of the line and on the same side of a transversal line, so is this one. If I do the same thing here, this one and this one, they're also called corresponding angles. But if this one is also equals to this one, therefore these two lines would be parallel. So in other words, if lines are parallel, the corresponding angles are equal. If lines are not parallel, the corresponding angles are not equal. So the thing ends at the angle ilingana le iba lingana le kuphela uma ngabe lama lines zomabili enjani parallel. If engekho parallel, lama angles awalingani, even though all of them are corresponding angles. What is it that we are seeing here? Ayalingana lama angles. So what does it tell us about these two lines? It means that they are parallel. If we say G1 is equals to B, because they are both equals to E, but these are corresponding angles. But these are corresponding angles. Therefore, line GH is parallel to line BC. Right. That's what we wanted to get. Therefore, GH, this one, is parallel to this one. Once Simone Gameniti parallel, zimbili izinto efanele iringe ekhanda lethu. When we talk about parallel, zimbili izinto efanele iringe ekhanda lethu. Number one, it's our grade 8, grade 9, when we've got two parallel lines that are cut by a transversal. That's where you should think of corresponding angles, alternate angles, vertical opposite angles, interior alternate angles, exterior alternate angles, co-interior angles. Also think of the revolution. When you talk of parallel lines, think of that. Number two, when you talk of parallel lines, the second part, when you see your parallel lines, is when you talk about this theorem. This theorem says that a line drawn parallel to one side of a triangle will divide the other two sides proportionally. So when you see the word parallel, tune to this part or to that part, depending on which one you'll be using at that particular time. Now, once we say GH is parallel to BC, GH is parallel to BC. We know that whenever we have a triangle and there's a line that's drawn parallel to that side of a triangle, it will divide the other two sides proportionally. We know that information, which is coming from this theorem, the second theorem in our lessons, proportionality theorem. Once you've got a line drawn parallel to one side of a triangle, it will divide the other two sides proportionally. Remember, there are two options. Option number one, we can say, once we've got a line drawn parallel to one side of a triangle, we can say AD over DB is equals to AE over EC. That's option number one. Option number two, we can say AB over AD. It is the same as AC over AE. Those are the two options that we can use in terms of proportionality. Right, let's look at where we are now. We've just shown that this is parallel to this one. So we've got this scenario now, where we've got this line parallel to that one. That's what we wanted to get at. so that we can be able to use that theorem. Now, to use the theorem, Euclidean theorem, remember now we've got a line drawn parallel to this side. So what can we conclude? We can simply say that this side, which is AG over GB, is equals to AH over HC. That's option number 1. Remember the second option that we just did that other side? Let's do it here. It's AB over AG. It is the same as AC over AH. Let's do it again. The second option, it will say AB, the longer one, over the shorter one, is the same as the longer one over the shorter one. All right. We should not we should not lose the sight of what we wanted to prove. We want to prove those. We want to prove that AB is equal to DE. Now, when we use our options, we should not forget this. We should not forget this. Sitinigela, almost AG over GB. Do we have something in final up? No. But once you say AB, do we have AB there? Yes, we do. So you can simply tell what the option of the 7 is here. Because we've got AB there, so we want to have this. This is what we want to have. So we can say AB, let's write that down. Therefore, AB over, it's AB over AG, right? AB over AG is equals to a line drawn parallel to one side of a triangle divides the other two sides proportionally. We've dealt with the side. Let's come to the side now. Remember how we dealt with this one? We said AB. So we do the same thing here. It's going to be AC. Do we have AC here? Yes, we do have AC. So we are safe. It's AC over, so it's AC over AH, over AH. Same thing to this one. Okay, let's move on. All right. AB over AG, because there's no AB over DE. That's no AC over AH, that's no AC over DF. All right, looking at that, we can now try and remove these two, because they're not here. Let's look at AG. Look at AG. Do you see AG? Do you see AG? Remember our construction? What did we say about AG? We said AG is equals to DE. AG is equals to DE. Let's indicate that. From our construction, we said this should be the same as this. This one must be the same as that. This is coming from our construction. So we can remember from our proof, these two now are now parallel. So we indicate all these things. We're saying AB over AG. Let me not conclude. Let me just get it first. But UAG is equals to what? UAG, in terms of our construction, is equals to what? AG is equals to DE. AG is equals to DE. And UAH is equals to what? Let's look at AH. AH is equals to DF. It is equals to DF. Therefore, we can write our statement as AB over, instead of AG, what can you write instead of AG? You can write DE is the same as AC over, instead of AH, what can you write? You can write DF. Right, that is how we go about proving this theorem. Similarly, in the very same way that we've proved this other one, we can show that BC is also equals to EF. So AB over DE, which we have here, is the same as AC over DF, which you also have that other side. In the very same way, BC over, it will also be equals to the other side, which is BC over EF. It is important that we should know that it is not only this side, also this one over that one is part of our similarity.